Hello everyone, welcome back to another video. This is the third part of environmental statistics in which we are going to know about the measures of dispersion. I have already made the video on the measures of central tendency. In case if you haven't seen that video, you can check it from the link given in the description. In today's video, all the important points will be discussed about range, quartile deviation, mean deviation, standard deviation and coefficient of variations. We will also see some questions, so make sure to watch it till the end. First of all, we must know that why these are called measures of dispersion. As around our surrounding we can see variations, that is very important for the biological phenomena, right? And we also observe that these all vary to a certain extent. In the previous video, we have already discussed that mean is the collective representation of any data set. So, to find out how the individual observations are dispersed around the mean of a large series, we use these measures of dispersion, which is designed to state numerically the extent to which the individual observations vary on the average. Measures of dispersion are classified as absolute measures and relative measures. Absolute measures of dispersions are those which are expressed in the same statistical unit in which the original data is given, whereas the relative measures of dispersions is the ratio of measure of absolute dispersion to an appropriate measure of central value, and it is expressed as a pure number. The relative measures of dispersion are independent on the units of measurement and they are used to compare the relative accuracy of data, whereas the absolute measures of dispersion may be used to compare the variations in two sets of observations which are having the same unit. The absolute measures of dispersion include range, quartile deviation, standard deviation and mean deviation, whereas the relative measures of dispersion include coefficient of range, coefficient of variation, coefficient of quartile deviation and the coefficient of mean deviation. Now let's know about them one by one. First measure of dispersion is range. Range is defined as the difference between the value of smallest item and largest item that are included in any distribution. In simple words, we can say that if we are having any data set, so our range will be equal to maximum value minus smallest value. Coefficient of range is the relative measure corresponding to range and is given by largest value minus smallest value divided by largest value plus smallest value. Let's see this example in which we have to find range and coefficient of range. For solving this, we will first arrange our data in increasing or decreasing order so that we can get the maximum value and the minimum value of this series. Here, the maximum value is 25 whereas the minimum value is 16. So, our range will be equal to 25 minus 16, that is 9. For finding coefficient of range, we will use this formula, that is largest value minus smallest value divided by largest value plus smallest value. So here we will get 9 by. Second measure of dispersion is mean deviation, which is also known as average deviation, as it is the average difference between the items in the distribution and the mean and median of that series. For calculating mean deviation of any series, first we have to calculate mean or median. Then we have to calculate the deviation from mean or median, by which we will get D and divide it by the total number of items. Mean deviation about the mean is given by this formula, and mean deviation about the median is given by this formula. Coefficient of mean deviation is another relative measure of deviation, and it is given by the ratio of mean deviation to its arithmetic mean or median multiplied by 100. Third important measure of dispersion is the quartile deviation. Quartile deviation is defined as the half the difference between the upper and lower quartiles. In the previous video, we have learned that quartile is one of the partition value which divides the 100 into 3 equal parts. The Q3 minus Q1 can be known as interquartile range because they are at the equal distance. So the interquartile range when divided by 2 becomes semi-interquartile range, which describes the quartile deviation. The coefficient of quartile deviation is the ratio of quartile deviation to its median multiplied by 100. Next most important measure of dispersion is the standard deviation, which tells us that how much a sample is deviating from the mean. It is the square root of arithmetic mean squares of deviation from the arithmetic mean and is given by this formula. So it is also known as root mean square deviation from mean. The coefficient of standard deviation is the ratio of standard deviation to its arithmetic mean. Next is variance, which is the square of standard deviation. So if we square the standard deviation, we will get the value of variance. Coefficient of variance is the product of coefficient of standard deviation, that is multiplied by 100. One of the most important topic is standard error of mean. In the previous videos, we have discussed about sampling, and it is very obvious that the sample, which is the estimate of statistics, will always differ one or the other way from the population. So this difference is given by the standard error of mean, and it tells us that how much precise is our value. Standard error of mean is equal to the standard deviation upon under root n. Here n is the size of the sample, and as we know that standard deviation tells us that how much our value is scattered in any series. For finding standard error when the populations are same, we will use this formula, that is standard deviation under root 1 by n1 plus 1 by n2. Here n1 and n2 are the size of the sample, and x1 minus x2 is the population. Standard error for the populations which are different, we will use this formula, that is under root sigma 1 square upon n1 plus sigma 2 square upon n2. Here sigma 1 and sigma 2 are the standard deviation of two different population, and n1 and n2 are the size of the sample. Now let's see that what are the factors affecting standard error. First one is the sample size. If we are having large sample, our standard error will be less. So we can say that sample size is inversely proportional to standard error. Second one is standard deviation. If there is more standard deviation, so there will be more standard error. In simple words, we can say standard error is directly proportional to standard deviation. Third one is the nature of statistics, which includes the mean, median, variance of the sample, and last is the form of the sampling distribution. Now let's see some questions to recall what we have learned today. After reading the question, I will wait for some seconds so that you can also guess the answer. Here, in this, we have to choose the correct statement. Statement first states that mean deviation is a better measure of dispersion than the quartile deviation, and statement second states mean deviation is obtained by dividing the algebraic sum of deviations about mean by total number of observations. So here, the statement first is correct, but statement second is incorrect, as when we calculate mean deviation, we do not count the positive or negative values. So our correct option will become option third. Next question is, the coefficient of variation can be measured by. So here the correct option will be option 3, that is coefficient of variation is standard deviation upon mean multiplied by 100. Next question is, which of the following is a correct statement regarding range as a measure of dispersion? So here the correct option is option second, which states that the range is independent of the change of origin but not on the scale. This is the last question in which we have to choose the correct statement. Statement A is about the standard deviation and statement B is about the standard error. This answer will be given in the comment section. So that's all for today. Hope you liked it. Till then, thanks for watching.